Welcome back. In this video, I'm going to show you how businesses can replace their subscriptions to platforms like Service to manage their ticketing system. Now, what you see here on the screen is my solution to these SaaS platforms, which is fully compliant to ITIL 4, ISO 9001, ISO and IEC 22 edition, as well as SOC 2, section CC7 dot 3 and CC7.4. Now, in terms of the system, this is the very basic demonstration of this incident problem register, where what you can see now is the front end dashboard. You're able to update a ticket, raise a ticket, of course, which is over here. So you could just raise a new ticket, resolve any ticket, raise a problem, also submit a root cause analysis for any P actual ticket that's come through. You've got your incident view, so your ticket view, where you're able to update as well as resolve tickets from this view as well. You've got the problem register, and obviously you've got your root cause analysis forms section. And then finally, the most important bit when it comes to compliance and audits, you've got your performance matrix. So what I'm going to show you is how to build this from scratch. I'll take you through the process of building out such a system internally in your business. I'm Misha McKenzie. I'm the lead governance architect for UNUS London. As well as that, I have over just nearly 20 years of working throughout the whole life cycle of Service Desk. And what I'm going to do is break down how this system is built, its purpose, and we're just going to take you through it stage by stage. Now, just to give you an understanding of what the purpose of the actual platform is. Now, the key thing to understand is that every issue that comes through IT, in terms of an IT issue, in terms of what's broken, or what needs to be updated or request for some sort of loan device or anything like that, has to be logged. There has to be some sort of alerts where the actual service desk admins are being alerted that a ticket has come through or a ticket's been updated and even a ticket's been resolved as well. Now, the system itself has to, for compliance purposes, be able to track and monitor in terms of when a ticket comes in and how long an actual ticket takes to be resolved. Now, when it comes to the actual auditors and receiving a report to find out the health of the service desk, the system has to be audit ready. There shouldn't be a case where you've got managers, service delivery managers, or even the IT admins running around searching emails, trying to put things together to make sure that they have everything together for their audit. The system itself has to be audit ready for an auditor to extract the information that they need as quickly and easily as possible. Now, this video is suitable for first-time builders, right? So I'm going to take you through the steps in terms of every node, every SQL query that is needed to set this whole system up and get things working. Now, what you're looking at on your screen right now, this course, I'm going to have a link in the description for you to download. So I've put in here some quick self-check questions that you could just test yourself in terms of the information that we're just going to go through. Now, let's just understand the language that's got to be used throughout this video. So when it comes to databases, basically a kind of like a filing cabinet for your records, all right, which is just permanently saved in that location. Now, when it comes to a schema, the schema is the rules of the database, all right? So a clear example is in terms of row level security, which we'll talk about in a moment, whereas there's rules set in place that only certain users can do certain things, whether it's read or write or even delete any information or data that's actually in the database. Now, when it comes to the actual logic of the system, that is run on a platform called N8. And in N10, if I just show you very quickly, the logic is put together by a series of nodes. So a single node step On the automation canvas is a box that either starts the process, which is the trigger. So here is the start of the process. This would be the trigger, or does something, an action connected to other nodes by lines. And these are the other nodes doing something connected by lines, which we're going to go through one by one. Now you've got the wording, which is webhook. And basically what the webhook means is that is usually a trigger. And this is where information that is sent from the front end is sent to your automation. So a way for an app to send automated messages or information to other apps in real time, triggering your automated alerts when a button in your portal is clicked. So your portal being your front end. Now, R means mean time to resolve. In terms of this, is how long does it take for tickets to be resolved from the time it's submitted. But there's other timestamps within the ticket system where a ticket is submitted, and there's also a timestamp in which how long does it take an admin to actually respond to a ticket and so forth. But in terms of mean time to resolve, especially in this demo, we're talking about the time the ticket is submitted to the time that the ticket is actually resolved. Next, we have A, which basically means root cause analysis. Now, this is very important for any P1 tickets, the most serious tickets, to understand why that P1 issue actually occurred, to make sure that there's steps put in place to ensure that doesn't happen again. Now, next we have SLA, and all SLAs is the service level agreement. So there's an agreement with regards to service desk and the business in terms of how quickly we're going to respond to tickets based on their priority, whether it's P1, P2s, P3s, and so on. The level of communication, the types of services we're going to provide, and how quickly and how efficiently we're going to provide them so it benefits the actual organization itself when it comes to any issues that they face. All right. So it's the agreement between the IT department and the business itself in terms of how they're going to deliver their support. All right. And then finally, we have cause, which is the cross-origin resource sharing. And this is just a small security, I'll say, feature that enables the front end portal to talk to the actual server that, in this case, N10 is sitting on. So when it comes to clicking an action, like clicking a button to trigger your webhook, cause enables that function from the front end, which is public, to securely trigger your automation on your server, which is obviously private. Okay, cool. Now, how this all fits together is you have your front end, which in this case, this is your front end portal. So you have your front end, which triggers your automations. You have your alerts. So in this example, we're going to be using Slack and Gmail. And of course, where the database is housed, which is in this case, we're using Postgres on Supabase. All right. So like always, we always start from the foundation, and the foundation is the database. So what I've done is I've separated the actual SQL phases into 13 different phases, and we're just going to quickly go through them so you've got a clear understanding. I am going to break these down in a little bit more detail further down in this module, but for now we're just going to look at this at a glance. All right, so the first phase, which is phase 0, we have the idempotency guards. Now all this does is it drops old objects, so that means that the scripts that we're going to go through, they're safe to basically rerun. All right, it won't break anything. The next phase is the item node types. Now this controls the vocabulary, so it just makes sure that the language is strict. It doesn't allow any typos. So for example, if it's going to use statuses, categories, P1, P4, P1, if it's going to be P1, it's going to be P, capital P and 1. It's not going to be priority 1 in terms of the word. So it's just setting out the actual vocabulary rules to ensure that everything's consistent. All right. Then you've got phase 3, that's setting up the SLA thresholds, which we've just spoke about. Phase 3, we need to set up the actual tables where tickets are going to be stored when they're submitted and also changed, etc. Then you've got the phase 4, which is incident transitions logs. Now, in this section here is where there's an audit trail for every status change. So for whatever happens from a ticket being opened to in progress, for example, to being resolved. Phase 4 ensures that every change in status is actually logged, making sure that's compliant to SOC 2 section CC 7.4. Next, we've got phase 5, which sets up the problems tables. So if we just go back to the front end, we've got the problem register. So we're setting up the table that's going to house this information. Okay, and then we've got phase 6, which sets up the root cause analysis table. We also got phase 7, which is the SLA breaches register. So this records every time a fix took longer than the SLA. And I have a quick demo on the dashboard which shows you an example of what the breaches look like. So you've got it here in terms of, okay, this has taken longer. So the SLA target in this example was 24 hours. The actual MTTR is 31 hours and 20 minutes, I would say that is. All right, so that is phase 7. Now phase 8 is the audit logs. So again, it logs every change that's happened in the ticket system itself. I've put here, it's the auditor's best friend. They get to see everything that's taken place on the system. Then you have phase 9. So these are the trigger functions. So the database automations, so auto set flags, timestamps, and again the MTT. So this function here is what, for example, when a ticket's submitted into the system, this will trigger off the stop clock, so to speak, to say, okay, ticket submitted, let's start counting down and timing how long it's taking the IT admin to actually resolve this ticket. Next, we have phase 10, and this is the sequence table plus the reference function. So just generates human readable reference like incident, the year, and a unique number. So in this case, it's phase 10 generates unique ticket numbers. Next, we have phase 11, and this is the compliance view. So pre-built queries for, again, the MTTR, open queue, weekly digest, trends. So if we go back to the dashboard, that is generally this screen here, as well as on the front where we're showing trends, incidents by priority over a period of days, etc. And phase 13, I've also provided some demo information. That's generally what you're looking here, so that you could just test the functionality before you decide to put it into production. All right. So now we've gone through at a glance of what the different phases of the SQL query that you would need to run in your database to set the foundation. All right. Here, I'm going to just go through very quickly the different queries themselves in a little bit more detail. So in terms of phase 0, and like I said, what this does is it drops every table, function, view, and type that the script is about to recreate using a cascade to clear out anything that depends on them. All right. So what that means is you're able to run this, and when you run the script again, so rerun the script again, it doesn't break anything. So running this phase wipes the listed tables. That's exactly what you want during the initial setup. But in production, you would run a proper migration tool. For this module, the script is designed for clean installs and reruns. Okay, cool. Let's close this one and move to the next one. So the next one is phase 1. So this is the controlled vocabulary. So this is the actual script you would run in your SQL editor in Supabase to set this up. And what this does is it creates 4 enum types predefined list of allowed values the database will accept, right? So it won't accept no typos. So for example, no P0 when meant to be P1. No in progress versus in progress with capital I, capital P, and a dash in between. So it's just strict controls in terms of the language used in the system. Okay. Next, we move on to phase 2, and this is the SRS thresholds. And this basically creates the thresholds table and sees it with response, resolve, and escalation targets for each priority level. Then the N8N workflow references the table when calculating breaches. So this is the table where we're able to calculate this actual metrics itself. All right. Next, we move on to phase 3, which is the actual incidents table itself. So, like I said, it creates a table, and this is the heart of the system. So every issue that the service desk ever logs comes with a timestamp, status, priority, security flag, RCA flag, and SLA breaches status. And the table is indexed on priority, status, opening date, breach flag, and reference for fast compliance inquiries. Now, in each of these, I have also put in here why it's important. And in this case, this table itself satisfies SOC 2 with regards to security event evaluation and SOC 2 section 7.3 and also section 7.4, which is incident response procedures, the timestamp trail. All right. Now, with the MTTR data computed here contributes to also the SOC 2 A1.2 section, where it's availability recovery evidence. All right. And I've put this under each one for you. Okay. Slightly digress there. Next, we've got phase 4. So the incident transition log. And again, all you need to do is just copy and paste this into your SQL editor. Actually, what you will get from the Governance Academy, you would get this all in one complete SQL script where you would just copy and paste it all in. And it has all the phases, all 13 phases in one whole query. But I've split this out so it's easier for you to understand what the actual doing. All right. Okay, so we've got the incident transitions log. This just basically creates a append-only incidents transitions table that records every single status change. All right, so from time it's open, in progress, to resolve, with who did it, when, how long it took, etc. Okay, again, why does it matter? Because it complies with this standard right here. Okay, we've got phase 5. Phase 5 is the problems table. So grouping the root causes. So creates the problems table where occurring incidents gets grouped under a single root cause. Now this is important for ITIL 4 problem management. Don't just fix symptoms, find the root cause and stop them from reoccurring. Okay, very important when it comes to service desk. It can be quite frustrating having to resolve the same issue over and over, and it's not really resolving, it's more kind of putting a plaster over it because it comes up again. So this is very important, finding the root cause of a problem so that it doesn't recur. It also complies with the ISO with corrective actions, which requires you to track fix deadlines. So permanent fixed target date is the deadline, and the view in phase 11 will flag overdue items. Next, we have phase 6, which is the root cause analysis, the investigation record. Now, what this does is it creates the root cause analysis table, which is a formal investigation document. So every P1 incident must have one. It's compulsory, and its purpose is to have an understanding as to why this P1 occurred, to make sure that it can be resolved and prevent it from happening again in the future. Very important for these standards here, which is ISO and IEC 27001. as well as the SOC 2 section CC 7.4. All right. And again, this is the full query here that implements this actual step, this phase. All right. Next phase, we've got phase 7, which is the SLA breaches register. Again, this just creates a table. The N8N workflow writes a row every time a resolved incident, and the MTTR exceeded the S target. All right, so if we go back to this, is where the actual SLA target was 24 hours, and it actually took 31.2. So this creates the actual table to calculate and house the results of the breach. Next, we've got phase 8, and this is the auditor's best friend. So this actually creates the log, a single catch-all append-only log that records the insert, the update, the delete operations on incidences and problems, capturing both the old and the new data as a JSON. The ISO IEC 27001 loves this. ISO 9001 2015 edition also loves this. That's why this is an auditor's best friend. So being able to, if you're an auditor, to go onto a business's site and ask to basically get an audit on the activity of their service desk, and being able to just generate a report in a format that they could get all the information, is always an auditor's best friend. And that is phase 8. Next, we've got phase 9. And what this does is set up the different triggers in the database itself. So this is not the N8N triggers. These are triggers within the database itself. So there's 6 triggers. Let's just go through them one by one. So one trigger is whenever there's a P1 ticket that's been submitted, that there's a RCA flag to ensure that there's a root cause analysis that is needed to be completed. Again, this is automatically triggered by the database itself. You've got a trigger for every time there's been an update on a ticket, whether it's been resolved or again in progress, etc. So every action on the database, it triggers an actual timestamp to say this has been updated at what time and so forth. You've got the MTTR trigger again, which is when a ticket is submitted, that's when the timer is triggered. And then when the ticket is marked as resolved, that's when it's triggered again to stop the stop clock and record the length of time. That information then will get used against the actual SLA to see if it was within the SLA or a breach. Okay, the fourth trigger here you've got for audit incidences, and basically this is a trigger that writes to the log every time there's a change to an actual ticket. Then you've got the audit's problem, which is more or less the same as the ticket, the audit incidences, which basically every time there's a problem, it adds it to the actual audit log. And then you've got the log for incident transitions. So why are these triggers important? So even if N8N Workflows forgets a step, the database wouldn't. All right. So every time a ticket is submitted, the database will always start the clock to calculate the MTTR. When information is changed on the ticket, i.e. it's been changed from in progress to resolved, the database will always remember to stop the clock and calculate and capture the time it took for that ticket to be resolved and match it against the actual SLA. This is automatic, regardless of whether or not your N8N workflows break or not. Okay, let's close phase 9 and open up phase 10, which is the sequence tables. And this basically gives every ticket a human readable ID. So this would be in Service Desk language, the actual ticket number. So you got the incident. In this case, I've put the year and the unique ticket number. All right. Next, we have phase 11, which is the compliance views. So it creates the SQL views that bundles complex queries into reusable objects your portal, N8N Workflow, and auditors can call by its name. So you got the incident metrics, you got the open tickets, you have the weekly digest, and you have the problem trends. And again, that, if we go to the dashboard, is the different metrics in terms of the trends, what's open, what's closed, what's been resolved, and the breaches, etc. Okay, cool. So you got your compliance views. Phase 12, you got your row level security. Now, what this does is it enables, in short, on every protected table, then create policies. Anyone authenticated can read, but only authenticated users can write to the main tables. The audit log is read only by application, and only triggers can insert into it. All right. Access control is very important when it comes to the foundation and the database. Why does it matter? Because it's compliant to the ISO IEC 27001 2 edition with regards to the information access restriction. Okay, so once access control enforced, RLS pushes the policy into the database itself. So even a bug in the application cannot bypass it. All right, cool. And this is that script here. So that was phase 12. And then finally, this is just the demo data. So insert 4 sample incidences. So I've got P1 in progress, P2, and so forth. And it's the reason why I'm giving you this is so that you could actually test the different functionalities to make sure all the features and everything else is working the way they're supposed to before you deploy it into production. Okay. Now, once you've run all these scripts, in this case, if you've got it from the Governance Academy, that one complete script that has all these 13 phases all put together, the next thing you should do is just to verify everything. So after the script runs cleanly, these 4 queries here below just confirms that every object exists and is populated. And you just run them in the SQL editor one by one, and each one of them should return rows with no errors. Okay, so you'll just copy and paste this, run them each one by one, and you should have no problems. Okay, again, I've put in here just a couple of fun test questions to test yourself in your own time, just to make sure that you've understood what we've just gone through here. All right, so the prerequisites. What do you need before you could get started? You definitely need to have a Supabase account. So you've got to have a SQL database. This is, in terms of this, is easy and small enough to set up on a free tier. With Super, I'm a key lover of everything in-house, and Supabase you are able to self-host, which again is perfect for businesses that need to be compliant to particular standards. All right, so you need to have Supabase your SQL database. You also need to have NA10, which is going to basically be the logic behind the system in terms of the automation. I would recommend version 2.0 upwards, preferably, but yeah, you can actually build this. The automations that's available in terms of the nodes and capabilities, you can do this on a version as low as 1.6, but I would recommend you use version 2.0 upwards. All right. Then when it comes to the alert system, you need Gmail or an email tool, and also Slack or some form of messaging tool like, I don't know, Telegram or Teams, for example. All right. So when it comes to the access and connections, Supabase needs to be able to talk to NA10. So your nodes in terms of NA10, I have here, for example, as you can see, I have my credentials set up, which is connected to the Supabase SQL database. Also, when it comes to your Gmail and Slack alerts, you've got to make sure that you have your credentials set up on each of the nodes. Okay. Finally, I've added this bit in here, mainly for beginners. Now, setting this up and connecting the Supabase to NA10, does involve entering the actual details and credentials quite a few times before everything's all fully connected. So to make life easier, especially for beginners, just have a blank document that you could paste the credentials in there, copy and paste and save everything and set everything up, and then delete that blank text document. I do not recommend you pasting or storing any credentials, any API keys or anything like that, secret key tokens or anything. I do not recommend you save them anywhere. But to make things easier in terms of the setup side, you can use that method temporarily, and once everything's all set up, you then destroy the actual text file itself with all the information on. Okay, so those are the prerequisites that is needed to before you could get started. All right, so let's talk about the actual build now. All right, so I mentioned about obviously setting up the foundation, and the foundation is the SQL database. All right, so you will just open up Super, go to the project dashboard. On the left hand side, you've got the SQL editor. You would open up the SQL file that I've provided for you to download from the Governance Academy. You'll copy all the contents, paste it into the SQL editor, and click run. All right. You should get a message saying success, that everything is perfect. Now remember, you are able to run this script multiple times without actually breaking anything. All right. Now, if you do encounter an error, what I have found is this 42710 error. All that means is that it's saying that the incident status already exists in the table. It is a possibility that you're using an old version of the script. And if so, just make sure you've downloaded the latest one and then try again and you should be all good. All right. So that is setting up the actual database itself. Now let's get into the actual n8n workflows. All right. I'm going to show you in terms of you building this from scratch. Obviously from the Governance Academy, you'll have a JSON file which will have all these nodes already here and with already configured. All it's needed is obviously for you guys to set up the credentials for the Postgres, Gmail, and the Slack node. But for the purpose of this video, I am going to take it a little bit step further and break down how this is built from scratch. All right. On a blank canvas, on the right hand side, you have loads of different nodes that you can choose from. And so when I'm referring to nodes itself, I'm referring to these individual nodes, which there are hundreds of different ones for different purposes from different companies, which have different features. Okay. So in that section, in the search box, so in the search box here, you would search for a node, for example, the webhook node, the code node, the if node, the Postgres node, Gmail node, Slack, or the respond to webhook node. All right. So you'll be searching for webhook, code node, if node, Gmail node, Slack node, Postgres node, and the respond to webhook node. That is what I'm referring to with regards to searching for node type. Now, when it comes to the actual settings for each node, all you need to do is double click into the node and you'll be exposed to the different parameters and then individual settings. These names of the nodes, so if I go here and do rename, these nodes reference the titles of individual nodes. Okay, so how a node speaks to another node, it will go by the actual title. All right, so click the node's name at the top of the settings panel and rename it to match the bold node name given in this guide. For example, classify, severity, and validate. This means more than it sounds. Later, nodes use expressions like curly brackets, $, generate incident reference, .item.json, .incident dash, which looks up data by a node's exact name. a renamed or misspelt node will break that lookup. All right. So these names you give to nodes are very important, because if there is a misspelling or a mistype, it will break the workflow. Okay. So just a key thing to remember there. All right. Now when it comes to connecting the node, we'll use this one as an example. All you're doing is clicking and holding and attaching it to the end of the node that you want connected. So you will just bring it up and let go, and it will just automatically connect to that node. Let me just make sure I save that. Okay. Now, there's only 5 automations that's needed for this current system, this current demo. And that's got to be the flow for new incidences, so new tickets. You've got the automation for any status updates on a ticket. That's this one here, this short one here. Next is the resolve and also the calculation of the MTTR. And that is this resolve incident workflow here. And you've got the weekly digest. So every Monday, emails to the service desk manager or even the service delivery manager on the performance summary. And the performance summary is going to be this performance metrics here. Okay. And that's the, move this out the way, go down, and that's the work here. Okay. I'm pretty sure I missed the RCA submission, but that workflow is right here as well. Okay. So let's start building. So we're looking at the first workflow, which is 8 nodes. So this workflow up here, the new incidents. Okay. Now we could scroll down here. First node, your webhook node. All right. The HTTP method is going to be post. You've got to put in the path, and you're going to use, with regards to respond, you're going to use respond to webhook node, because you want this webhook to respond when the automation reaches this end webhook here. Okay, so let's start building out these workflows. All right, so first we're going to look at the new incident intake. That is this first workflow here. Okay, so at a glance, you've got the webhook, you've got 2 code nodes, you've got the if node, Postgres node, Gmail, Slack, and the respond to webhook node. So the first code node basically checks the required fields, it classifies the priority and sets the SLA targets. The second code node basically builds the human readable ticket number reference. Now you've got the if node that decides whether or not that the ticket has come through, whether it's a P1, P2, P3, etc. And depending on where it's gone, it will take its relevant path. And so that's what I've put here, decides whether to fire immediate alerts. And then you have the Postgres node. So this is what inserts the record into the actual database. And that's this node right here. Okay, now you've got the notifications. So you've got Gmail alerting admins of a P1 and P2. So emails the on-call responder for high priority incidents. And then you've got Slack, and it posts the same alert as the incident. So it basically sends the on-call responder high priority incident notification in Slack. And then you've got the webhook node that just basically confirms back to the portal, so back to the front end, back to here, that basically the automation went through successfully. So that's the workflow at a glance. And let's just look at how we set this up. So you've got the webhook node. We've got this webhook node, and you're going to set the method to post. So let's click here. You've got to set the method to post, and you also have the actual path. So you've got your path, and then you set your response to respond to webhook node. Finally, you also want to set up your cores. And again, what this is to enable the front-end portal to securely trigger your workflows in NA10. Cool. Next, we'll move on to the first code node. You will just open a code node. You will just copy all this in. And all this does is, again, In plain English, this node checks the title, priority, category, and reported by were all filled in, and stops the whole workflow with an error if not. So it checks the priority is of a P1 to P4, then works out whether this incident counts as a high priority, whether an RCA will be mandatory, and what the SLA response resolve targets are, and attaches all of that to the data flowing onwards to the next node. So you will just open up the code node, make sure you have that title, and you will just copy this whole code here. This is just basically JavaScript, and you would paste it into the code node here. All right, very straightforward. Your next code node, which is connected to the first one. So remember, you're just making sure each one connects to the other one as you're going along. You would just copy this in. And just to let you know, so what this does is this generates your unique ticket number for each ticket. All right. Next, you have the priority branch. So in this if node, it determines if the priority is a P3 or P4, or P3 and P4. P3 or P4 will go down this route and the ticket will just be updated in the system. But if it's higher, so P1 and P2, not only is the ticket added to the system, but also alerts go out via Gmail and Slack. All right. So this is where you set the conditions. So the priority is not equal to P3, not equal to P4. Next, you have the Postgres node, and this is where it actually updates the information into the ticket system. Now, remember, this node needs 2 incoming connections. All right. So one incoming connection is tickets that are P1 and P2. They also get updated to the database, but also alerts go out via Gmail and via Slack. And then also tickets that are lower priority, so P, are also added to the database. So always remember, this node needs 2 incoming connections. All right, so you'll drag a line from both the true output and the false output of the priority branch into the same node. Every incident gets saved regardless of priority. Now, inside that Postgres node, obviously you've got it connected to your Supabase. The operation is going to be insert, the schema is going to be public, and the table is obviously going to be the incidents table, right? And then I have provided the bits that needs to be linked up. So you've got the incident reference, the priority, the category, the title, and so on. All right. So all you'll do is you would already have these tables when you sync. When you select the correct table, it will show up with these headings, and you can literally either copy and paste this or take it from the side view of the input in NA10. For beginners, I would just recommend you just copy and paste what I've put here for each section once you've actually followed the steps or the previous steps exactly as how I've laid it out. All right, cool. Next, we're going to move on to the actual notification nodes. So in this case, it's the Slack and the Gmail. So again, you will connect your credentials to the Gmail node. The actual email is going to be the on-call responder. So that's the IT admin itself. And the subject is going to be a high alert in terms of this P1 or P2 ticket is high priority. And then this message here, which basically takes the information of the ticket in terms of the ticket number and puts it in a nice HTML format for you. There we are. So you've got high priority and it has the relevant information about the high priority ticket for the IT admin to then go in and resolve it. Okay. Next we have Slack, which is basically doing the same action as the Gmail node. So in this node, you would again connect up the credentials. For Slack, it's the bot token. You will select your particular channel in Slack that IT admins will receive notifications from. So let's just say for this example, the channel is called incidents. And then you will have a short message saying urgent message, including the priority, reference, title, category, etc., etc. Okay. Next, we've got the respond incident is created. So that is the end of the actual workflow here, which is the respond to webhook node. And all it does is respond back with this JSON message, just letting know that this information has been sent to the portal, and the person who raises a ticket will see their reference number. All right. So that is the step-by-step guide in terms of how to build the first. So if I just minimize this, we will go to the next one, and this is the status updates, which is just 4 nodes. All right. Now the goal of this is to build the automation that records every status change. All right. So every status change in a ticket is recorded. This is 4 nodes. So at a glance, this is just a webhook node, a code node, Postgres node for the database, and again ending with a respond to webhook node. And the purpose is obviously the webhook, as you now understand, is where we receive the information from the front end. The code node in this workflow basically unwraps the webhook information into more simple fields that would then get later on used to update the information on a database. The Postgres node basically updates the incidents record with its newly changed status, and then the respond to webhook node responds back to the front end, letting that user know that it's gone through. So once again, if I quickly scroll down and we'll zoom in a little bit, you've got the status change webhook. Again, it's the HTTP method is post. Got to make sure that your cause is configured to ensure the security is in place between the portal and the server that N10 is sitting on. Then you would open a code node and connect the webhook to that code node. Just copy this code in, and this basically again just extracts the necessary information from the webhook node, which is the incident reference number, what the new status is, who's it's assigned to, and so on. The next node, of course, is the Postgres node, this one here, so that it can update the database with the new status. So you got your credentials, the operation is update, the schema is public, and the table is, of course, the incidents table. Now the columns that you need to match, it has to match the incidents reference number, so the unique ticket number, it matches that record in the database, and then updates its status, who it's assigned to, and other metrics as well. Okay. And then finally, you have the respond to webhook node, which again, once everything goes through, responds back with the information and the timestamp. Okay. And that's this 4 node workflow right here. All right. Let me zoom out a little bit. Okay. So next we have workflow 3. And this is the resolution of the ticket and the calculation and recording of how long it took for the IT admin to resolve a particular ticket. All right. So this workflow here, at a glance, what does it do? You've got the webhook again. You've got the code node, which basically cleans up the webhook data and puts it in more readable data, or more useful, extracts the useful information from the webhook that will be later on be used further down the workflow. You've got the Postgres node, and what this does is look up the incident to find out when it was originally opened. And then you've got another code node now that calculates the resolution time. So it will calculate when the ticket was actually opened to when the status was changed to resolved, for example. All right. Next, you've got the actual Postgres node, which then updates the incident with the final results from the calculation that was done on the previous node. So that incident now is then updated with its MTTR and any breach flags if it's been breached. All right. So the Postgres node updates the database, and what it will show us is whether or not the ticket has breached the actual set SLA. All right. Then you've got the if node. So you've got the if node here. Did the ticket breach the SLA, true or false? And if it is true, you've got a Postgres node that logs the breach as a permanent audit evidence. Also, you have a Gmail node that then notifies the service desk manager or the service delivery manager of said breach. Okay. And then you've got the webhook node. So you've got the update of the database of the breach, and you've got the notification. All right. Excellent. So let's quickly break down into the individual nodes itself. So again, you've got your webhook set to post in terms of HTTP method. You've got your path set. You've got the response set to respond to the webhook node, which is the last node in your automation. And you've allowed the cause or set up the cause to enable the security between the portal and the server for the automation. All right. So that node, you will then connect to the code node that will take all that information from the actual webhook node and just extract the incident reference number, so the ticket number, who it was resolved by or changed by, and the resolution summary. And it will just ignore all the rest of the data that may come through with the webhook as well. All right. So it will clean up the response from the webhook. The next node after that now will use the incident reference number, so the ticket number, to find the ticket itself. Okay. So the Postgres node set up with your credentials. The operation is select. Schema is public, of course, and the table is the incidents table, of course. And the where is where the reference number is equal to the reference number or the ticket number that has come through the actual webhook. Okay, so this Postgres node is going to find that exact ticket because every ticket has a unique number. Okay, cool. Now, once it finds that ticket, it'll be able to determine when that ticket was open, and the code node, so this code node here, that code node then calculates how long that ticket took from the time it was open to the time it was resolved, and determines whether there was a breach to the SLA. Now, based on that results, all results, not based on the results, all results from that code node is then added to the database. So you have now the actual Postgres node set to mark incident resolved. Now, what that does is how you set that up is you obviously set up your credentials. The operation is update. The schema on the table is public and tables, and the column that you need to match in the database is the unique ticket number. All right. And now in that table for that ticket, you're going to update the status, the resolved at, the MTTR hours, the breach, the resolution summary, as well as who it was assigned to. All right. So all that information is updated in the database, and then later on can be shown here on the front and on the dashboard. Okay. Now you've got the if node. So this node here determines whether, based on the actual calculation, did that particular ticket breach the SLA? And if so, it goes to the actual database for the breach to be recorded, and also a notification goes out to the manager. So when it comes to the if node, the condition is true or false. Did the SLA breach? If it's true, the fix took longer than the SLA is now, and if it's false, the resolution was within target. So add the Postgres node connected from the true output to the SLA breach check only. All right. So it did breach the SLA. You're going to add it to this node, which then writes the record to the database. All right. So it's insert, schema is public, the table is SLA breaches, and you're going to input this information. So the incident ID, the reference, the priority, what the target was, and the actual time it took to resolve the ticket, and obviously the breach, the difference, which is referred to as breach delta. All right. And then next to it, you're going to set up the notification, which is going to be an email. Again, you set up your credentials. The email is going to be sent to the service desk manager or the service delivery manager. The subject line is going to be breach, and it's going to have a HTML summary of that breach. And if we go in here, I do this, and so you've got a summary of the breach itself. Okay, lovely. So what we just looked at just now, that was the resolve incident workflow, where it changes the status of the actual ticket and calculates the resolution time. Now we're going to move on to the workflow 4, which is the root cause analysis submission node. So whenever there is a P1, it is mandatory that a root cause analysis is done to find out what caused it and to put systems in place to ensure that it doesn't happen again. That is this short workflow here, this 4-node workflow. So once a root cause analysis is filled in, so if we go to the portal and we go to here, so once this form is filled in and is submitted, what that does is it triggers this workflow. And how you build that out is, again, you've got your webhook node. Make sure you've got the cause set for the security between the portal and your server that's hosting the NA10. You're then going to have the actual code node. And what this does is, this basically, it's the same idea as the workflow 1. It gives the actual root cause analysis its own unique ticket number, right? So it's a unique identifier for that root cause analysis. Okay, next you have the code node. That's this code node here. And the purpose of this code node is to basically give the root cause analysis a unique reference number. So I've put here like a friendly reference like RCA 2026-7734. So a unique identifier for this root cause analysis. Then the next node is the Postgres node, which updates the database with this information. Again, your credentials. The operation is going to be insert this time. The schema is obviously public, and the table is going to be root cause analysis table. And you're then going to add this information in that's going to update those columns in the database in that row. Again, just copy and paste this into each of these sections, as long as you followed my instructions, all the previous instructions to this point, exactly how I've laid it out. And then finally, it ends with the actual webhook, respond to webhook node. And all it does is give a message going back to the front end portal saying RCA submitted for review. And that's it. And then finally, we have the weekly report that goes out to the service desk manager or the service delivery manager, which is the weekly digest email. That's this workflow here. Let me zoom in. Okay, so it has a schedule that is set to basically trigger on a Monday, 8 a.m. What it does is it fetches the weekly metrics. So it pulls the latest performance numbers from the database. Then you've got the code node that takes that information, puts it in a nice HTML format, and then the Gmail node sends that report to the manager or the service delivery manager. All right. So you've got the schedule node set to Monday at 8 a.m. Very straightforward. So days between trigger is one day, 8 a.m. Okay, so you got the first node. All you got to do is set the trigger rules. Set a rule to set the trigger at 8 a.m. on a Monday. Next, you got the Postgres node. Oops. So you got the Postgres node here. Connect it up with your Supabase credentials, of course. The operation this time is called select. The schema on the table is public, and it's going to be your weekly digest, right? And you just set a limit of 10. You can be more, but it can be more or less. I would say just do 10. Then you've got the code node itself that is going to take the information and put together a nice HTML. So I've created that for you. I've just built out something very simple for you. We'll get to see it in the Gmail node, but you could just basically copy this and paste it into your code node. And then the final node is the Gmail node, where you link it up to your credentials. You'll put in the email of the service desk manager or the service delivery manager. You've got your subject and you've got your title. And if we quickly have a look at that here, you've got your title and you've got your, in here you would have your message, which would be generated by the actual code node. Okay, so that is the breakdown of the individual workflow. Now, connecting your credentials and activating your workflows. You've got to remember that you've got 7 Postgres nodes. All right, they all need to be connected to the same database. You've got your, in this case, Gmail node. So you've got your node for your email notifications. In this actual system, there is 3 Gmail nodes. You've got to make sure that you've connected to your actual Gmail account properly through. You've got 3 nodes, which is your Gmail node. You just need to make sure that you've connected to your account via the authentication process. And also you've got your Slack, which again could be your Teams or Telegram or whatever messaging system of your choice. But in this case, it's Slack, and you just need to make sure that, again, that is connected with Slack. I believe it's your bot token. Once that's all set up and configured, to go and activate your workflow. Now, just to quickly give you some steps with regards to connecting to your Postgres. So in the actual settings, and now I'm doing it here because in the actual demo itself shows mine. So I've done it here, whereas on Supabase, the information you're looking for is the host, the database itself, the user account, the password. Make sure that your port is set to 5432 and enable SSL. When it comes to connecting, you'd only need to do this once. So you'll do the whole sign into Google, follow the OF prompts in the pop-up window. As well as that, you also have a step within your Google Cloud to make sure that you've got your Gmail API enabled. I'm not going to go through that in this video. I may actually do a separate video in terms of how you set up nodes to these accounts. That's something to think about. Or I may actually provide links to other YouTubers that I actually follow that has already detailed tutorials on how to do that. I may actually do that. I'll go through some of the other YouTubers that I follow who's actually gone through these steps in terms of setting up your Supabase credentials and your Gmail to NA10 and things like that. But here is just a very basic at a glance view of what you got to make sure that you do. So again, click the credentials. There's a process you need to go to wherein you sign into Google and follow the prompts in the pop-up window. Slack, with regards to Slack, you need to go in and create a new Slack API using your bot token. And once that's all configured and all set up, you would then set your workflow to active or publish in that. So just like here, publish workflow, and it should turn green and say published once everything is all set up in place. Now, in terms of the course, the goal here is to allow your front-end portal to securely send messages to your NA10. So whenever you actually do a function, let's just say, for example, write transition, that action is completed securely. Generally, if there is a security problem, it will get blocked from your actual front-end portal and your automation will just never be triggered. Now, in terms of this example, I have NA10 hosted on a VPS server via Docker. This step is not optional. I'm only providing an example in terms of Docker. I'm not going through in this video how you set NA10 up in Docker on your VPNs. That's a whole separate video in itself. I may actually do a video on that myself or provide you links with other YouTubers that I follow that's actually got their own detailed tutorial on how to do this whole step yourself. But generally, enabling the browser communication, in this case, as Docker is what NA10 is set up in Docker, I would open the Docker compose file, YAML file on the server, find the environment section, and basically paste this in. That's it. Save it, restart the container. So restart the actual container following this command once I've SSL'd into SSH'd into my VPS server, and that is done. But this is a very important step. If this step is not done, no matter what you do on this front end, it will not talk to your automation in the back end. Restart NA10, and then finally it's the dashboard. So now again, the dashboard is available to the full HTML is available to download from the Governance Academy. You will just download that. Oops, let's go back here. You will just download that, open that up in your actual browser. You'll click down here. So we're under configuration. You'll click webhook config. You'll put in the URL to your database. You'll put in your Supabase REST, your Supabase URL to your actual product, and then you'll also put in your secret key, which again you get from Supabase itself. That's a separate video in terms of how you acquire that, but you'll put that information in here, and then you would test the connection. And what you should see is a success. So NA10 is reachable, and once you get that results where everything is green, that tells you that your security between the portal and NA10 has been configured properly. All right, and then you're good to go. Again, I've provided you with some questions here to just give you a little pop quiz. But now that you've got all that set up, we need to make sure that you're able to test the system and make sure it works from start to finish. So what you're going to do is you're going to pretend to create a ticket. You're going to check your email and your Slack to make sure the alerts come through. You're going to change statuses. So you're going to change the status of a ticket. You're going to change the status of a ticket and make sure that function works. You're going to resolve a ticket, and you're going to submit a RCA and make sure that your automations are actually being triggered from the front end. And you're also going to manually trigger your weekly digest to make sure that emails are actually going through with the actual report. Okay, now that you've built the system, here's the thing where is the most important and why this system's important. That system that we've just gone through is compliant to these standards here. These standards, for example, the SOC 2 C77 section C77.3 determine whether software bugs are actually security threats. All right. The portal satisfies this by explicitly forces responders to answer, is this a security event on every single issue? Now, SOC 2 section CC7.4, what this requires is for you to prove that you follow the procedure to fix things. All right. And how does this satisfy it? There's an unchangeable log of every status change given that gives auditors the mathematical proof of your actions. So everything that you do on a ticket is automatically logged and cannot be changed. That is just solid proof. You've got the SOC 2 section A1.2, wherein you need to prove you can recover from outages. Cool. This system, the database automatically calculates the time an incident occurs to the time that it was resolved. Again, tamper proof, so it can't be adjusted or manipulated to suit the purpose of the audit. Once that's put in place, once that timestamp has been captured, it cannot be edited. All right. So how does that prove that you can recover from outages? How does that prove it is the fact there's proof that, let's just say, an outage has occurred in terms of a ticket, a P1 ticket, for example, and there is a record that shows that within the MTTR time that the service desk, the IT admin or whoever was able to resolve that time within the SLA, and here's the record. So there's proof that the service desk or the business recovered from the outage within this length of time. Next, you've got the ISO IEC 27001 2022 edition. And what this requires is thorough investigation of major security issues. Now, this is where the root cause analysis comes in. So what this system does that you've just built, This system automatically forces a mandatory root cause analysis document for any critical P1 incident, and this is mandatory. Next, you have the ISO 1 2015 edition, and what this requires is track corrective actions and fix deadlines. Now, this system, what it does is that the problem register links multiple incidences to the single root cause and enforces a permanent fix target date. And then finally, you have the ITIL 4 incident and problem manager. And what this does is restore a service fast. What this requires is that services is restored quickly and the root cause is found and obviously addressed. Now, with this system, the automated SLA counter and timer and priority routing, whatever way you want to say it, right? What this does, this proves the framework is being followed precisely. So once there's no breaches, the actual agreement in terms of P3 tickets needs to be resolved within 24 hours, and the system will show that the tickets that has come through with the MTTR in place, it shows that tickets are actually being resolved within the set time frame set by the service level agreement. Cool. That, along with again some quick knowledge questions, little tests, little fun quizzes to keep you fresh. But now you've pretty much built out the system. You're ready to go live once you've tested everything out and you're happy that all the workflows is gone through. So you just make sure that your cause, you could use this as a little checklist. So as you check each one, you could just tick them up, but you just make sure that your foundation is set and successfully deployed with no errors. Your workflow is active and can communicate with your front end portal. All your messaging notification applications that you want to use, whether it's Gmail, Hotmail, whether it's Slack or Teams, for example, you make sure all your credentials is correct and connected to the nodes. You want to make sure that all your portal buttons, in this case, what I mean by that is any of your action keys. So all these actual buttons itself, that's meant to trigger workflows, these webhooks. Just make sure they are all working. You can, depending on how you've installed your NA10, again, I'm referring to those that's got theirs containerized within Docker. If your NA10 keeps crashing for whatever reason, you could just run this to run Docker logs, NA10 --tail, etc. Run that in your terminal just to see what's going on with the logs. But outside of that, you could reach out to me via the Governance Academy, and I will go through things with you and make sure you're set and you're good to go. So I'm going to leave this in the description below. You could just click this, download the HTML, open it up in your browser, and use it to work through and build out this incident and problem register. Okay, until the next one, keep building. Okay, see you on the next video.